Hello, welcome back. I'm Rajendra Bade, and in this video, you are going to study sections of prisms and cylinders. Read this problem. A hexagonal prism is resting on HP with its axis vertical and two of its faces parallel to the VP. The prism has height 45 mm and base edge is 25 mm long. It is cut by an AIP inclined to the HP by 50 degrees. The cutting plane cuts the axis 20 mm above the base. Draw sectional front view, sectional top view, sectional side view, and true shape of the section. Now listen, it is a prism, not pyramid. So this object doesn't have apex. It is hexagonal prism, that means it has two hexagonal surfaces. If axis is vertical, then lower hexagonal surface is base and upper hexagonal surface is top of the object. So it has altogether 12 corners, 6 corners at base and 6 corners at top. Prisms have rectangular faces. Okay, let's read the problem. A hexagonal prism is resting on HP with its axis vertical. Axis vertical, very important information. It means its base hexagon is in the HP and two of its faces parallel to the VP. Remember, when hexagonal prism is vertical, that is its axis is vertical, all faces, there are 6 rectangular faces, all faces appear lines in the top view. So you are going to show or draw a hexagon in HP with two of its edges parallel to the VP. Two of its edges parallel to the VP. So let's proceed. Draw XY line and proceed with the true shape of base. So to draw hexagon, as usual, you draw two lines, a vertical and a horizontal, to establish center, and draw a circle of radius equal to edge of the hexagon. So edges of the hexagon are 25 millimeters long. So draw a circle 25 millimeters. Label all the base corners with letters, and listen, label the base corners also with the numbers. Remember, there is no apex here. This center of the hexagon represents axis in the top view. Since axis is vertical, it appears a point in the top view. Edge A1, it is vertical edge. It appears a point in the top view. So there are 6 vertical edges. This object is vertical. Axis is vertical, and therefore all face edges are vertical. Remember, in case of prisms, face edges are always a parallel to the axis. Okay. So there are two hexagonal surfaces, one at base, the other one at top, and base and top hexagons overlap in the top view. So here there are two hexagons. One is lettered hexagon and the other is numbered hexagon. And these two hexagons will appear in the front view, one at base and the other one at top. So let's proceed for the front view. So this is how, as usual, we have drawn projectors. This is projector for axis. So axis is vertical and length of the axis, height of object is nothing but length of the axis. We should measure 45 millimeters. So measure 45 millimeters vertically, and here is the top surface. So 6 base corners on XY line and 6 top corners 45 millimeters above the base. So this is how front view is over. Now check whether you are asked side view. You are asked sectional side view. So let's draw side view as usual. A 45 degrees line and transfer all these points in the side view. Letters on XY line and numbers at distance 45 millimeter. So all 6 base corners labeled with letters in side view and all 6 top corners labeled with numbers. This is position of the object: top view, front view, and side view. Now, second important step is to locate cutting plane. It is a cut by an AIP. It is a plane perpendicular to VP. So we should draw cutting line in front view. It is at an angle 50 degrees. So we'll draw cutting line at an angle 50 degrees. The cutting plane cuts the axis 20 millimeters above the base. So first we'll locate the point 20 millimeters above the base on the axis. Let's do this. So 20 millimeters are measured vertically, and corresponding point you will get on axis. So here is the point on the axis which is 20 millimeters above the base. Now through this point we'll draw cutting plane at an angle 50 degrees. And this is the cutting plane at an angle 50 degrees. And this is second important step. After this, simply label points of intersection of edges and cutting plane and transfer these points in the top view and in the side view. but still there is something new in this problem on prisms. Try to understand. So as usual, I'll start labeling the points of intersection of cutting plane line and face edges. So here it is PF. It is intersection of cutting line and this vertical edge through F. That is edge F6. PB is on edge B2. PE is on edge E5 and PC is on edge C3. So cutting plane line intersects 4 face edges. Now listen, here cutting plane intersects base edges. So label this point as U and V. Since it is front view, of course, we should use dash here. So U dash and V dash. Now, it's not a pyramid, it's a prism. It has identical surface at the base, identical to the base, it has surface at top. So where cutting plane line intersects top surface, here also it intersects 2 edges at top. So label this point with letters S and T. Remember, in case of prisms and cylinders, when cutting plane line intersects numbered surface, we are going to label there always 2 points S and T. It's better to have a standardized method for labeling. So remember now, when cutting plane line intersects base, label U and V, and when cutting plane line intersects top, label S and T. Of course, there will be a surface at the top in prisms and cylinders. There will be numbered surface in prisms and cylinders. Okay, so now count the number of corners the section has. Remember, when cutting plane line intersects an edge of an object, it creates a corner. So S and T are 2 corners at top, PP, PF 2 more corners, PC, PE 2 more corners, and U and V. So now the section is an octagon. It has 8 corners. So these 8 corners we are going to transfer in the side view and in the top view. Okay, let's proceed. Now watch. U and V on lettered edges. So U is on CD and V is on DE. Now S and T on numbered edges. So S is at top, matlab on edge 1, 2, and T is on edge 1, 6. Now focus on edge PB and PF. Now try to understand. Corner PB is on edge B2. This point PB is on edge B2. So transfer this point PB on edge B2 in the top view. Where is edge B2 in the top view? So this corner. Because all face edges are vertical, all face edges A1, B2, C3, D4, all these face edges appear corner in the top view. So B2, this corner, is not just a point, it is edge B2 in the top view. Point PB is on edge B2. Therefore, point PB in the top view is on this corner. On edge B2 means on this corner B2 because this corner is edge B2. This is how PB is on this corner and PF is on edge F6, matlab on this corner. So let's proceed. So watch here, PB and PF. Similarly, PC. This is how PC and we have marked PE. Check. All 8 corners are there in the top view. Now let's transfer all these 8 corners in the side view. Let's first transfer corners on the base, U and V. So here it is U, and here it is V, here it is S, and here it is T. So this is how we have taken help of top view to transfer points on the base and points on the top, S and T. So S and T in the side view at top and U and V are on the base. Now PB, PF by drawing horizontal projector and PC, PE also by drawing as usual horizontal projectors. So PB and PF, PC and PE. So this is how we have transferred all 8 corners in the side view. Now portion nearer to observer is removed portion. The view in which cutting line is, that view gives you clear idea about removed portion and retained portion. Make edges on the retained portion dark. All edges, that is base edges, face edges, top edges, their portion on retained side you must make dark. So base edges, here top edges horizontal, and these are all face edges. So watch here, PE to E, this small, it is retained portion of vertical edge. PB to B, retained portion of edge B2. Also PF to F, it is retained portion of edge F6. Edge 1A is completely retained. So we have made a retained portion dark. In the top view, let's complete the section first. Simply join all these 8 corners to form a closed polygon. Remember, section is a surface, newly generated surface. It must have a closed boundary. So simply join these corners to form a closed polygon. Similarly, in the side view, join these points, 8 points, to form a closed polygon. So this is how we have drawn section in the side view. Now make a retained portion dark. Check this corner I have made it dark, and also this corner I have made it dark. Watch here, BC portion, BC. It is on the retained side. That means this corner of the object is retained. In the side view also, this corner is retained. Watch here, AGEF. AGEF is on the retained side. Matlab this is retained side. Watch here, 3-2. Edge 3-2. It is on the removed side. That means this portion is removed portion. This portion is removed portion. You need not worry about the lines inside the section. No hidden or visible edges inside the section. Remember, you are simply going to draw hatching lines in or on the section. In the top view, watch here. After drawing the section, this portion, check it. D4, edge D4 is on the removed side. That means this portion is removed. Check on the left hand side of point CE, this side. It is removed side. So don't make this portion dark. On the right side of ST, it is retained portion. So make this portion retained. Now, draw hatching lines on the section and then true shape of the section. So nothing new in drawing true shape of the section. Make this cutting line, which is front view. The cutting line is in the front view. So make front view of the cutting line parallel to XY line. Transfer all these 8 points which we have labeled with red color. Transfer all these points on the horizontal cutting line. Use compass. Exactly the same distances to be transferred here on the horizontal cutting plane line, and then draw horizontal projectors and vertical projectors to complete the true shape of the base. So finally, this is the drawing. Now let's read this problem. A cylinder is resting on HP with its axis vertical. Diameter of the cylinder is 60 mm and its axis is 70 mm long. In this position, it is cut by a cutting plane perpendicular to the VP and inclined to HP by 30 degrees. The cutting line cuts the axis of cylinder 40 mm from the base. Draw sectional front view, sectional top view, sectional side view, and true shape of the section. Now, it is a cylinder. So it has a circular edge at base and a circular edge at top. Axis is vertical, so true shape of base is in HP. So draw true shape of base in HP. It is a circle of diameter 60 mm. Then there are no sharp corners involved at the base. That's why divide the circle in 8 parts and label those 8 points in the top view. So let's proceed. So this is how that cylinder I have completed top view, front view, and side view. Now listen, it is not a cone, it's cylinder, so it doesn't have apex. So don't label the center. Instead, these 8 points on the circle, you label with numbers also. Then project these points in the front view. Height of the prism or cylinder is given. So major height 70 mm. Lettered surface is at base. The numbered circular surface is at top. And since you are asked side view, draw side view also. Remember, A1, B2, C3, D4, these are all generators and not edges. Never make generators dark. Remember, in case of cones and cylinders, never make generators dark. You should make only boundary of retained portion dark. Okay, let's proceed. Second important step is to locate the cutting plane. In this position, it is cut by a cutting plane perpendicular to VP. Remember once again, if a cutting plane is perpendicular to VP, it appears a line in the front view. So we are going to draw a line in the front view. Inclined to HP by 30 degrees. So line at an angle 30 degrees. And the cutting line cuts the axis of the cylinder 40 millimeters from the base. So where is axis? So from the center of the circle, the vertical line is, this is axis of the cylinder. So on the axis, from base, measure 40 millimeters. And through this point, you draw the required cutting plane. Let's do that. So 40 millimeters from the base, we have identified a point on the axis. And then cutting line at an angle 30 degrees through the axis. This portion nearer to observer is removed portion, and portion which is nearer to XY line is retained portion. The view in which cutting line is, that view gives you clear idea about a removed and retained. Okay, once you have located the cutting line, label points of intersection of cutting line and edges of the object. In case of cones and cylinders, we don't have face edges, and that is why we draw imaginary lines on the surface called generators. Now, label points of intersection of cutting line and generators with letter P. So this is how I've labeled the points. PA is on generator A1, PB is on generator B2, and so on. Cutting line, if it cuts base, then U and V. Cutting line, when cuts top, then label those points as S and T. In this case, cutting plane line doesn't intersect base surface or top surface. So all these P points, these are the points on the edge of section. Remember, generators are not edges. So these points, these P points are not sharp corners. In case of cones and cylinders, P points are to be joined by smooth curve. Okay, let's transfer these points in the side view and also in the top view. Now simple. PA is on generator A1. Where is generator A1 in the top view? So this point is generator A1 in the top view. And PA is on generator A1, matlab on this point. So PA you will get directly on this point. Similarly, PB you will get directly on this point. PC directly on C3, matlab on this point. PD is on D4, matlab on this point. It means all these points, P points, you will get on the circle itself. And when you transfer PA in the side view, PA is on generator A1, and this is how you transfer all the points in the side view. So check here, all points here on the circle, and in this case on the respective generators. Now join these all these 8 points by a smooth curve and not by straight lines. In case of cones and cylinders, points are to be joined by smooth curve. So let's do that. Here I have made first retained portion dark. The view in which cutting line is, that gives you clear idea about retained portion and the removed portion. This is the removed portion, it's retained portion. Check here, I have not made other generators dark, only boundary of retained portion dark. This is what I'm telling you again and again. In case of cones and cylinders, make only boundary dark. I've seen many students making this mistake. They draw all other generators also dark. You will lose marks in exam. Remember, let's proceed. Now transfer all these points in the side view, which we have already transferred. Join these points by a smooth curve. Also join these points by a smooth curve. That will be section in the top view, and here section in the side view. Let's do that. So section in the top view is the same circle again, and here how it appears an ellipse in the side view. Now make retained portion dark. Only boundary you should make dark, and it is already dark in the top view. So top view, sectional top view is complete. Side view, check upper portion, this portion is removed portion, and lower portion, this portion is retained portion, but it's cylinder. So only boundary of retained portion you should make dark. So this is how I made boundary dark. Now hatching lines in the section. So sectional front view, sectional top view, and sectional side view are ready. Now for true shape of the section, simply make this cutting line, which is in the front view, parallel to XY line. Front view must be above XY line. So here above XY line, we'll draw this line horizontal, and we'll transfer all these points on the horizontal cutting line without changing distances between these points. So use compass to transfer all these distances here. So this is how I have transferred all these points here. Okay. Now, in this case, transfer all these points now in the top view, and from adjacent top view, draw horizontal lines. So remember, all these red points you are going to transfer here for the true shape. So let's proceed. So draw horizontal projectors, and this is how you complete the ellipse. Now, let's solve this problem. A cylinder has diameter 60 mm and axis 80 mm. The cylinder is lying on the ground with its axis perpendicular to the VP. It is cut in such a way that true shape of the section is an ellipse with major axis 85 mm. Draw sectional elevation. Elevation means front view. Sectional plan, that is sectional top view. Sectional profile view, that is your sectional side view, and true shape of the section. Remember these alternative terms you use for front view, top view, and side view. Okay. Now something new in this problem. Earlier, all problems we solved, axis was vertical in each of those problems. When axis is vertical, true shape of base appears in the top view. In this problem, cylinder is lying on ground with its axis perpendicular to VP. Now axis is perpendicular to VP. So true shape of base appears in the front view. Listen once again very carefully. When axis is perpendicular to HP, in other words, when axis is vertical, true shape of base appears in the top view. And when axis is perpendicular to VP, true shape of base appears in the front view. So in this case, first time we are going to draw true shape of base, that is circle. It's a cylinder. So true shape of base in the front view. Then the true shape of base will be a circle. We'll divide circle in 8 parts. We'll transfer those points in the side view as well as in the top view. So let's first draw views of the cylinder in given position. And what is the given position? It is lying on HP, lying on ground. So in front view, the cylinder should touch XY line. And in front view, it is a circle. That is true shape of its base. Let's proceed. So watch here. First draw the circle. That is true shape of base. And then you draw XY line. That will be easier, touching the circle. Then as usual, divide circle in 8 parts. Here it is front view. So I have labeled those points with letters as well as numbers. And we have used a dash for all those letters and numbers because it is front view. So in the top view, at any convenient distance from XY line, draw top view of the cylinder. So generator A1 now appears a point in the front view. Axis appears a point in the front view. And generator A1, here it is, boundary generator in the top view. Like all other generators, B2, C3, D4 and all 8 generators are there in the top view. Now since we are asked side view, we should complete the side view also. So project all 6 base corners and numbered corners here. These are of course not sharp corners. So this is how all generators and all those 8 plus 8, 16 labeled points in the side view also. So this is the position of object. Remember, very important step is the position, and second important step is location of the cutting line. It is cut in such a way that true shape of the section is an ellipse with major axis 85 millimeters. Draw sectional front view, sectional top view, sectional side view and true shape of the section. Let's proceed for location of the cutting plane. Okay, now I have located the cutting plane. Try to understand here. It is cut in such a way that true shape of the section is an ellipse with major axis 85 millimeter. It is cut in such a way that true shape of the section is an ellipse. So now its lateral surface we should cut. So cutting plane line I have located in the top view. Major axis is overlap of cutting line on the lateral surface. So this overlap we should manage 85 millimeters. And how to do that? From this corner, take radius 85 millimeters and draw intersecting arc on the other side. So this is how we have managed overlap of cutting line on the cylinder, which in the top view, 85 millimeters. It is not possible to have that 85 millimeter overlap in the front view. Also, it is flat surface of the cylinder. Base surface is flat, top surface is flat. So cutting flat surface will not give you an ellipse. You should cut the curved surface, and that is why cutting plane line should be in the top view. Okay, once you have located the cutting line, remaining part is as usual. Label points of intersection of cutting line and generators with letter P. So let's proceed. So PE is on generator E5. Here there are 2 generators overlapping, D4 and F6. So PD and PF, PC and PG. Now check this corner. This cutting plane line passes through point 1. Point 1 is a point on generator A1. So I've labeled this point also as PA. PA is on generator A1. PB is on generator B2 and so on. Now transfer these points in the side view on respective generators and also in the front view. As usual, PA is on generator A1, at the same point A1. PB is on generator B2 and PH is on generator H8. And this is how all these 8 points you will get on the circle here in the front view. Let's proceed. So this is how I have transferred all the points in the side view on respective generators. I have transferred these points in the front view also. Join these points by smooth curve. So this is section in the front view. And when you join PA, PB, PC, etc., these 8 points by smooth curve, you will get section in the side view. Hatching lines on the section. Section is newly generated surface. Remember now, we are going to make a retained portion dark. in case of cylinders, only boundary of the retained portion you should make dark. Now here this in front view, this entire circle is at boundary of the front view only. So sectional front view is over. In the top view, where cutting plane line is, here you get clear idea about retained and removed. Portion nearer to observer is removed portion. Portion nearer to XY line is a retained portion. So here I'll make retained portion dark. And here also, this portion, which is nearer to observer. So it is removed portion. Or you can say that the portion in which numbers are, that is removed portion. So numbers, that is removed portion. And base side portion, that is later portion is retained portion. So I have made a boundary of retained portion, and only boundary of retained portion dark. Don't make other generators dark. Take care. So sectional front view, sectional top view, sectional side view are over. Now one more very important thing you should understand here. Major axis is given 85 millimeter. So I took 85 millimeter in compass, and from point 1, this corner 1, as a radius, I cut this boundary generator, so that we got overlap of cutting line on the top view as 85 millimeter. Now important thing is, why should we choose this point 1 to draw the arc? So reason is, it is better to have cutting plane as close to the observer as possible, so that the retained portion will be maximum possible. We should keep larger portion as retained portion and smaller portion as removed portion. Okay, so this is how we have chosen point 1 to locate the cutting line. Now true shape of the section as usual. Here cutting line is in the top view, so horizontal cutting line will be in the top view, that is below XY line, and true shape of the section you will get in the front view. Let's proceed. So here I have drawn the cutting line parallel to XY line. Transfer all these points without changing distances here on the horizontal cutting line, and then vertical projectors, adjacent front view horizontal projectors, and you will get the required ellipse. So this is how we got the true shape of the section. Check here, it is cut in such a way that true shape of the section is an ellipse. Watch here, true shape of the section is an ellipse with major axis 85 millimeters. 85 millimeters. Okay. Now, why cutting plane line is not in the front view? Why cutting plane line is not in the front view? So simple. If you draw cutting plane line in the front view, then cutting plane line will intersect the base. So you will get two sharp corners U and V, but an ellipse must not have any sharp corner. That is why we should not draw cutting plane line in the front view. So we decided to draw cutting plane line in the top view. All these details are very important when you solve such type of problems. Okay, let's proceed. So this is final drawing. It is true shape of the section. All given dimensions you should show in the diagram. So cylinder axis length, base diameter, and true shape of the section with major axis 85 millimeters. Let's solve this problem. A triangular prism, base edge is 60 millimeter long and length 90 millimeter, is resting on HP. One of its rectangular faces is in HP, and the axis is parallel to both the reference planes. In this position, it is cut by an AIP in such a way that true shape of the section is an isosceles triangle of base 50 millimeter and altitude 75 millimeter. Draw sectional front view, sectional top view, sectional side view, and true shape of the section. Okay, it's a triangular prism. True shape of base is triangle. We should start with true shape of base. We should start our drawing with true shape of base. So first we should draw that equilateral triangle, that is base of this prism. Base edges are 60 millimeters long. So true shape of base is an equilateral triangle of edges 60 millimeter. But most important thing is, in which view this true shape of base will appear. Now read. One of its rectangular faces is in HP. It's very important. It is a prism. It has triangular base, identical triangular surface at top, and faces are rectangular, and it has one of its faces is HP. In this problem, it's not a base in HP. Axis is parallel to both the reference planes. So in this case, we consider HP and VP. Axis is parallel to both the HP and the VP. Now, when axis is parallel to HP and also parallel to VP, you should realize that axis is perpendicular to side plane, profile plane. So true shape of base appears in the side view. If axis is perpendicular to VP, true shape of base in front view. If axis is perpendicular to HP, true shape of base in top view. And when axis is perpendicular to profile plane, true shape of base is in side view. In this case, we are going to draw true shape of base in the side view. Okay, let's proceed. So here it is XY line and X1 Y1 line. This is VP where you should draw front view. This space is HP where we should draw top view. And this is the space profile plane where we should draw side view. Let's proceed. Side view is equilateral triangle now. True shape of base appears in the side view. And one of its faces. Now you should understand, in case of prisms, when you draw true shape of base, then in that case, those edges of true shape of base are not simply edges, those are rectangular faces. And we want one of its faces in HP, that means on XY line. So we'll draw equilateral triangle with one of its edges on XY line. So 60 millimeters, this is one of the edges. Don't make it dark at this stage. Remember, we are solving problem on sections of solids. So unless we draw cutting line and we cut the object, we must not make any single line dark. So let's proceed. This is how we have completed equilateral triangle. This is true shape of base. ABC, we'll label these corners, but don't forget that it is a prism. So one more identical surface will be there, triangular surface, we'll label it as 1, 2, 3. So ABC and 1, 2, 3. So two triangular surfaces coinciding in the side view. This is true shape of base view. Now look at center of the triangle. This point join corner to the midpoint of opposite edge. One more corner with midpoint of opposite edge intersection is a center of this equilateral triangle. It is not just center of the triangle, it is actually axis in the side view. Axis is perpendicular to profile plane and therefore it appears a point in the side view. Now we are ready to draw sectional front view. In front view, axis length. Axis is parallel to both of the reference planes. So axis will show true length in front view as well as true length in the top view. So measure true length of axis. Leave some space. So front view must not touch X1 Y1 line. Leave some space, any convenient space, and measure true length of axis. And this is how a triangular surface on this side and triangular surface on this side, and axis is showing true length. So project edge C3, edge A1 and edge B2 also in the side view. And this is axis which is 90 millimeters long. Label all the corners. So ABC, A double dash and A dash on single projector, C double dash and C dash on single projector. So this is how we have transferred all three corners A, B and C. Numbered corners will be on this side. So triangular face, this is the triangular surface and this is the other triangular surface which is numbered, and this triangular surface is later. Now let's proceed for the top view. So as usual, projectors from front view to top view and projectors from side view to top view. And this is how, check here, projector from side view of point C and projector of point C from front view. Where they intersect, that is point C. Similarly, projector from A and projector from A. So here it is point A. So in this manner, we transfer all the points in the top view. 6 labeled points, A, B, C and 1, 2, 3. So this is how we have completed views of the prism in given position. This is the first problem in which we have drawn true shape of base in the side view. Let's proceed. Now let's look at cutting plane. In this position, it is cut by an AIP. AIP, auxiliary inclined plane. It is a plane inclined to HB and perpendicular to VP. Perpendicular to VP, that means cutting plane line is in the front view. It is cut by an AIP in such a way that true shape of the section is an isosceles triangle of base 50 millimeter and altitude 75 millimeters. In this case again, exact position of cutting plane is not given. We are asked to locate the cutting plane so that true shape of the section is isosceles triangle of base 50 and altitude 75 millimeters. Now check, try to understand how we should think in this problem. Cutting plane, no doubt it is in the front view, that's given, it's an AIP. It should intersect three edges of the object. Now when cutting plane is in this orientation, then you will get one corner for the section here, that is PC, and cutting plane is intersecting triangular surface which is numbered. So here we should label this point as S and T. So 2 points here on the numbered surface and here 1 point on face edge C3, that is PC. So if cutting plane is in this orientation and in this manner, we'll get a triangle. Now how will you transfer these points in the side view? Check here. S dash T dash, S double dash T double dash. S double dash is on edge 1 3 and T double dash is on edge 2 3. So this is how you will get base of section, and PC is on edge C3, that is on this corner. So this is how you will get section in the side view, and it is an isosceles triangle. But we don't want just an isosceles triangle. We don't want just an isosceles triangle. We want isosceles triangle of base edges, base edge 50 and altitude 75. So this edge we should manage 50 millimeters. So how to get correct cutting plane line? Try to understand. Measure 50 millimeters symmetrically. That is 25 millimeters and 25 millimeters from axis of symmetry. And this is how you will get S double dash and T double dash. So this is that line S double dash T double dash, 50 millimeters long. If you want base of section, which is an isosceles triangle, you want base of section 50 millimeters. So you must have S double dash and T double dash in this position. And if you want S double dash and T double dash in this position in the side view, S dash and T dash must be at this position in the front view. So project S double dash and T double dash in the front view. So cutting plane, if it cuts numbered surface at this point, then you will get S dash T dash here, and in turn you will get S double dash T double dash 50 millimeter long, that is base of an isosceles triangle. Now cutting plane line is in the front view and axis is given 75. So overlap of cutting plane line on front view of the prism, we should manage 75 millimeters. Now try to understand how to do this. Take 75 millimeter radius and from ST cut edge C3. So cutting plane line passes through S dash T dash and PC. Draw the cutting line. So this is that cutting plane line. Once you have located cutting plane line, remaining procedure is same in all the problems. Transfer these points in the side view and in the top view. Point PC is on edge C3. So in the side view, it is on edge C3. And edge C3 is a point here. So PC is on this point here. So PC I have marked, that is same as C and 3. Okay. So side view may all three corners we got. Now transfer all these points in the top view. S and T. So this is how we got S and T in the top view. Now PC we can take it from front view. Now all three corners are there in the top view. Now join these corners to form a closed polygon, which is an isosceles triangle. So this is section in the top view. This is section in the side view. And in the front view, section is a line. Now hatching lines in the section and retained portion dark. So I made a retained portion dark here. The view in which cutting line is, that view gives clear idea about retained and removed. Portion nearer to observer is removed. Portion nearer to XY line is retained. Now we'll make retained portion dark in the top view. Check here. Edge A1 and edge B2 are completely retained, and that is why in the top view edge A1 and edge B2 are completely retained. Edge C3, only this portion is retained, PC to C. So PC to C, this portion is retained. Now entire base ABC is retained, so I made ABC dark. And on this side, check here, 1 dash and S dash. It is retained, so in the top view 1S and T2 must be retained. Now in the side view, check again. Below ST, the portion of the prism is retained. Below ST, portion of the prism is retained. So make it dark. Now let's draw hatching lines in the section. In the side view also. Retained portion we already made dark. Now to draw true shape of the section, as usual, draw cutting plane line parallel to the reference line or XY line. Transfer these three corners here. Use compass to transfer these points on the horizontal center line. Now by drawing vertical projectors and horizontal projectors, we'll get true shape. Section is a parallel to HP now. So in the top view, we'll get true shape of the section. Vertical line through S, horizontal line through S. Vertical line through PC, horizontal line through PC. And this is how, as usual, we have transferred all the three corners on the true shape. Now join these corners and you'll get the true shape. This is the required true shape, which is an isosceles triangle of base 50 and axis 75. Now insert all given dimensions in the diagram. So length of the axis 90 millimeters. We have used that 75 millimeter axis of true shape here. That is why this 75 millimeter appears here on the parallel center line, and therefore we get axis of true length of axis in the true shape of section. Okay, then this dimension is given, length of base edges of the prism, and size of true shape also given, axis 75 and base edge 50. Now label true shape of the section, and now we can say that drawing is complete. Thank you for watching this video. I'll see you soon in my next video. That will be final video on sections of solids. Bye bye.